And live.
Hello, good morning, everybody. How are you today on this, well, in the UK, kind of wet, cold, sleety, snowy Saturday? I hope you're having a fantastic day already. And welcome to my session on Understanding Microservices, a guide for the monolithic developer. That was me until recently. I was a monolithic developer. And that's kind of why I wrote this talk, because I thought, this is a little bit difficult to understand all the nuances. So I want to help share the knowledge that I've accumulated recently with all of you. Now, if you have questions, you can pop them in Discord and I will pick them up as I go along if I think they're relevant. If not, I'll save them for the end. And we should have time at the end of the session for all your questions. So got the clicky thing on the wrong place. A little bit about me. My name's Layla. I am a developer advocate at VMware. I am also a Microsoft MVP, GitHub star, if you know what one of those is. I used to be a director on the .NET Foundation, and I am the co-organizer of MK.NET, my local .NET user group here in Milton Keynes, because that's where I am broadcasting to you from right now. So let's go into this question. So you have decided you need microservices. You've been to all the talks on distributed systems and microservices and why you should have them and everything that they do for you and your application and your project and all that good stuff. Are you sure? I have to ask this question because the thing is, microservices is a huge undertaking. There are so many considerations to take into account before you actually embark on it. And we're not going to go into those today. We're going to assume that you've been through all of that and you are 100% sure. If you are still on the fence and you're like, I think it could be good, maybe it would be good, I'm not sure, then you're not sure. Don't embark on it until you are 100% sure that this is the right path for you, because it is a big undertaking. So you've definitely decided that you need them, and that's where we're going to leap off. What do you do now? I mean, have you read anything about all the different technology that you need to do microservices? When I started reading up on it, I was like, what is all this gobbledygook? The names. I mean, developers are notoriously bad at naming things, but if you go and look at all the technology around microservices and distributed systems, it gets really interesting with all the names. And they just get weirder and weirder. Half of them you can't pronounce. If you try and search for them, like you go and search for Prometheus, well, now you're finding alien movies, which isn't a bad thing. I'm rather partial to alien movies, but not when I'm trying to find out about things to do with microservices. So there is a plethora of names. Where do you even start? I mean, this is a big area. You're going to have to re-architect everything, think about all of this. Where do you start? That's a huge decision. And how do you even go about creating a proof of concept? How do you get the technology in place? There are so many different aspects of it that you need to think about and make sure that you're happy with before you go and embark on it. So let's think about where to begin. As I said, this is one of the hardest bits that you need to do. Do you start with a refactor? Is it a complete rewrite? A fresh start on it all? Do you do it in stages? Like, for example, you might have your monolith and you want to extract some of the services into it and to say, as your functions, that's a start. You might do little stages like that. Keep plucking bits of your monolith out. And then you just start going about that. But there's also the bigger picture, how do you divvy up your teams? How do you get everyone, to work on a part of the project that they're suited to? How do you make sure that people have enough knowledge of all the different moving parts? How do you move them from team to team? How do you manage your sprints? How do you do all of the people-y things as well? And how do you project manage and plan? And brain is melting because there are just so many different aspects of this that go beyond the code. But we're going to just look at code today. But I just want to make sure that everyone is aware of the huge undertaking this is. And you need to have enough people on your team to make it worthwhile. And I can't decide whether I'm using this or I'm using my mouse. What I'm going to start with is a glossary of terms, because this is one of the first things I encountered. Yes, there are all these brand names, but these brand names were of things that I didn't even know of. The first one is service registry. And this is how applications and services and instances of those services locate each other. I mean, they're all here in this ether of the cloud. How does one application know where the other one is if they're being dynamically scaled and turned on and turned off? How does anything know where anything else is? API gateway, now that's probably more familiar because you can use that in any type of development. And this is a server that is a single entry point into the system. So all external and front end traffic routes through this gateway, sometimes called a reverse proxy, and goes to all your backend services and vice versa. Load balancer, again, probably familiar. And this is how traffic gets distributed across all your backend services. There's things like round robin, so it just goes from next service to next service, or it may be like, well, that one's busy, we'll leave that one, this one's doing nothing. There's lots of different ways to go to it. External configuration, this was a new one to me, and I was quite like, oh, why haven't I thought to look for that before? This is all your configuration in a centralized store. So you're not hard coding anything into an application. So when the application starts, it goes to the external configuration and gets all of its configuration, which makes it much easier to manage. Everything's centralized. If you have to cycle keys, you're just doing them in that one place, not having to root through all these different applications and update their environment variables or whatever their configuration is. So that was pretty cool. Circuit breaker. I was like, what is all of this? This one's quite interesting. I'm going to give you sort of like a rough big picture description of what this is, quite simplified, but bear with me. If you have your application, and then you have another application over here that's sending traffic to that application. Let's say application that's receiving all that data is going, I can't cope, there's too much coming, stop, 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 I'm just going to grind to a halt. This application over here that's sending off these requests is like, I don't care. Keep sending them. This application hasn't told this application that it's failing, it's overwhelmed. This application just keeps sending stuff. Something's going to happen here. Things are going to get lost. This is not a good situation. Bring in the circuit breaker, and this sits in the middle here, and it's monitoring. And if this sending application keeps sending stuff and the circuit breaker notices that the receiving application is drowning in requests and can't keep up, it starts taking those requests and buffering them. And then it watches the receiving application and it sort of feeds it a response when it's ready, and it gradually increases the rate of it whilst it recovers and comes online, or other instances come on, whatever's happening. And then once all the traffic is back to normal, the circuit breaker steps back and traffic resumes as normal. So that seems quite cool. And bounded context, that gets bounded around quite a lot. This is two applications, and this is kind of the interface of the context that maps between them. So if you have a user object on this application and one on here, it's that context that maps the two together. Okay. So that's just a rough overview of some common terms that come out into it. Now, I love a good analogy. It helps me visualize things. So we have the Tanzu Tacos project. This is an e-commerce food ordering site. Things go crazy on a Tuesday. I wonder why that is. Well, anyway, they need to scale up on a Tuesday. They want to scale to meet business demands. Maybe that's on another day, a holiday as well. And they want to easily add in new services like order tracking, notifications, whatever they think of. They want to be able to put that in easily without disrupting existing services. So we're going to go through and look at all the different aspects that we need to think about for Tanzu Tacos to move over to a distributed system. Let's start by looking at the monolith that is Tanzu Tacos. It's got all the usual type of services. It's got the user interface, data access, ordering, payment, identity, notifications, admin, catalog management. You've got to have somewhere to store all of these tacos and the toppings and the drinks and the nachos and everything that you can order. So that's all in the monolith. Now, remember I said earlier, you might have done something in stages. Well, we've done that. We've extracted the UI sort of into a customer client. And that's now being shifted over onto the browser. So now the client, the customer, their browser has taken some of that load. And we've also taken the notification service out because that seems like a good one to pass off to queuing, asynchronous stuff. That could be in an Azure function, for example. So we've just pulled that out, and that's a nice unit of work, so to speak, to pop over there. So this is looking like a nice start. But now I want to talk about scope before we go any further, because we're starting to divvy up all of those different things within our monolith into individual services, and scope is at the heart of this. Now, we have our food truck. It currently serves tacos, but imagine if it also served hot dogs, burgers, pizza, noodles, rice, sushi, and desserts. I mean, you've been to a restaurant where they serve all sorts of things, or a buffet. Not many people have been to a buffet in the past 2 years, but you've been to one of those buffet restaurants that have all these different cuisines around the place. They're never that good at doing at any of those dishes, are they? You know, it's kind of like a jack of all trades, master of none. I think that's a bit of a mean phrase sometimes, but in this case, how good do you think that sushi is going to be? Like, are you going to order sushi from a place that serves tacos and pizzas and hot dogs? Probably not. So the scope of a service is vitally important, and the key thing that you need to remember is that a service should do one thing and do that one thing well. Sorry, I have a real cough this morning. I'm sure it will pass. So you want to really think about what each service needs to be doing and scope it to that one thing. I often get asked, well, how big should my microservice be? How many lines of code? Because quite often people want to measure things in lines of code. Well, your microservice should be as big or as small as it needs to do that one thing well. It doesn't matter if it's big and it has loads of different processes in there that it has to do that one thing. Doesn't matter, it's still doing that one thing. If it's tiny, a minimal API, and it's got like one endpoint, that's fine too, if it's scoped correctly. So you just want to really think about that scope, okay? And as long as your service is operating within your scope, you're fine. All right, so let's have a look at the scope then. If we have a customer UI on Tanzu Tacos, we've got that displaying food items and it's collecting orders, because we don't really want our user to be doing other stuff. This is handling all interactions with user. That's its scope. The food service, that is responsible for serving up all seat. I don't know why my taskbar is showing, actually. I've just noticed that. Let me see if I can come back and get that. No, my taskbar is still going to show. I'm sorry about that. So this is responsible for serving up all available food and drinks. So this is just a catalogue. It just passes out information to everybody. Then the order service. This just deals with creating orders. So that's the customer sending the order in, it creates them. It just deals with managing orders on its own. Payment service, that just deals with payments. It probably talks to a third-party payment API, you know, like Stripe or PayPal or whatever service you're using to process payments. So that just deals with that. And then we've got a notification service. Remember, we'd already taken that out earlier into an Azure function or similar. So that's just off on its own, doing all the notifications. So that all seems quite good. I haven't covered sort of the management portals or anything here. It's going to be more of the same, and I don't want to overcomplicate the example. So now that we've got everything scoped, we can scale each one of those services independently whenever we need to. And now Tanzu Tacos is ready to roll. But let's go and see about the communication side of it. We've sort of spoken about all these services, but how does the payment service know when there's a new order in to go and take payment? So let's have a closer think about how our services should communicate with each other. So the first thing we're going to look at is synchronous communication. And you're probably all going, synchronous? Because let's have a look what's classified as synchronous. HTTP, gRPC, SignalR, TCP. But you're all going, wait. No, that's asynchronous, Layla, because when I go and write my new HTTP client in my code, I put a wait in front of it, and I have to put async on my method. That's all async. But let's step back and look at the big picture. If I make a request to my catalog service, I want a response. I'm not going, oh, here's a request. I don't care when you get back to me. We want that response. We don't want our customer hanging around waiting for some food items to display. We want it then and there. That makes it synchronous as a big picture level. So anything where you need an instant response and you're waiting for that response is classified as a synchronous communication. So the asynchronous communication is where we basically fire and forget. We don't care. We just say, hey, here's an order, deal with it. And the order service is like, I've done my bit, I've created an order. I don't need to do anything more now. And there's two types. We can have queues, which is better for one-to-one communication, and we can have buses, which is one-to-many. I corrected this the other day. I must have corrected a different version. So that should be one-to-many buses. Okay, so that can talk to many different things, and that's through topics. That it's much more flexible and extendable. You can use things like RabbitMQ. You can use Azure Service Bus. There's loads of different buses. They also support queues, many of these, but you just want to decide on which one. Steve Adalis has a really good blog post on whether to use a bus or a queue. So if you're confused about that, go and check out Steve Adalis's blog. Let me drop that into Discord right now. Excuse me. Alrighty, so let's have a look at our services and how they're all going to communicate with each other. We've got our client service, and that's going to talk to the food service, and that's also going to talk to the order service, and that's all synchronous. We want our food items to be displayed instantly. We want that response. We're not hanging around here. We want to make sure that the customer knows that their order has been placed. Some people may argue that the order service could be asynchronous, but I'll leave you to decide that on your own system and what suits you. But in the case of Tanzu Tacos, we are having everything synchronous for that order service. Right. Now, if we shift over to the back-end services, we've got the order service, the payment service, and the notification service. We're going to have those all communicating via a service bus of some sort, so a bus, and that's by a publish and subscribe model. So let's have a think about what that does. Our order service, it gets in an order and it goes, okay, I've got an order, it needs payment, and it publishes a message out and says, here's an order that payment needs to be taken from. So it has a topic. The payment service is subscribing to that topic and it goes, oh, there's a payment. I'll deal with that. Give it to me. So it goes off, does the payment, and then it goes paid and sends out a message back on to the pub sub. The order service then goes, oh, okay, I'm looking for things that are tagged paid, and it takes that and it updates the order. The notification service is also looking for things that are paid because it wants to send an email or a text or whatever to the user saying, hey, we've got your payment, thanks. And each different event that happens is going to just get published, and whatever is interested in it is going to subscribe to that topic. And all of that is happening asynchronously. So let's go and have a look at the big picture of everything. We've got our client and customer and food service, so a client, food service and order service, and it's all linking together now. If we draw out a little bit bigger and think about the admin site, that could be connecting via HTTP to the food service. This is for updating catalogs, etc. You may have a similar admin site connecting to the order service and things like that. We also have a kitchen client, so they can process the orders. So those would be asynchronously delivered to the kitchen service. And then Signal R seems like quite a nice way to communicate with the kitchen client. So it's real time updating all the time. So now we want to think about the, I've skipped on too much. Where are we? There we go. So now we can add in different layers and different parts of our application without disrupting anything else. Because we can just publish things to the pub sub, we can add in that kitchen service and it can just subscribe to another topic, and everything just fits in nice and harmoniously. Now, the next thing we're up to is data and what to do with it. I mean, this is at the core of any application. So we've got all of our services that we just saw a moment ago, and we probably have a big old bucket of data. Huge, that's it. As a monolithic developer, this is what we're used to doing. We may have a second database, but generally speaking, we probably have just one big, massive database. But we don't really want that in our microservices. We don't want to couple all of our services to one big database. So what we want now is to have a database for our food service, for the order, payment. Each service has its own database. And I get a lot of pushback and questions around this when I've spoken to people, and they're like, well, why? Everything's repetitive through it. But if you think about, if you update something on the order service and you're updating the order model, now you maybe have to update some of the fields that the payment service is using because it was also using that order service. So now not only do I have to run a migration in my order service, I have to sort of do that in the payment service. And now I've coupled my order service and my payment service together via their data, and we want everything to be as loosely coupled as possible. It also gives us a lot of flexibility around the type of data store we have. So for example, our food service may just need cheap table storage, like in an Azure blob storage. It doesn't need a relational database, nothing like that. It's just cheap and cheerful. It doesn't get updated that much, isn't searched. It just, here's some data, passes it up, and that's that. Our payment service may need to be highly scalable. It may need to be sort of super fast, Jira redundant, who knows what it might be. So you may want like a document DB, like Cosmos DB to be there, and that's expensive. So you probably want that tightly scoped to just payment service. You don't need that type of data service for your food service. Your order service may have a relational database such as SQL. SQL Server rather, and because it's got user data, you want some redundancy, you want backups and all of that. So now you can choose the right type of data for your service. You don't have to be like, well, this really doesn't need a relational database and blah, blah, blah. You can just make everything have the type of thing that suits it. And I think that's really powerful. But now you're probably wondering, well, how does everything, there we go. How does everything sync up? And that's a phenomenon, not a phenomenon, a thing called eventual consistency. And this is a model used in distributed systems where eventually everything will have the same data as the last updated value. So this again will go via like the pub sub. It will say, okay, I've updated order to say paid, and everything else that has is listening to whether an order is in a paid status, an unpaid status, whatever status this is, will get that event, it will subscribe to that, and it can update its models or its data to say this order with this ID is now paid. So eventually everything is on the same page. Alrighty. So security again, cue the silent groans. I can hear them from here. They're not so silent, I'm afraid. I can hear you. So we've got two types of security that we need to consider here. And the first is machine to machine. And this is ensuring that only approved apps like the client app can access data that doesn't require user sign-in. And to explain that a little bit further, if someone comes and they want to see what food we offer, what type of tacos, what toppings, we don't want them to have to log in to be able to see that. We want them to be able to browse anonymously. However, we don't want any old application being able to access our food service. So we need to make sure that the app that they're browsing the food catalog from is authenticated to talk to our food service. And that's known as machine to machine. So the client app is authorized to speak to the food service, not the user. And then on the other hand, we do have user authorizing and authentication, just as you would normally have with a login, and that is business as normal. So if you want someone to be able to make an order, they're going to go and sign in, so they have all their details, we've got them authenticated, yada, yada, yada. So that's our usual sort of modus operandi. Now your security options, we have a few here. We can have cookie-based, and that's where the client web app stores the cookie. We can have token claims. That's where you don't have anywhere for your cookie to be stored. And we also have IAM, which is Identity Access Manager. And you can use any plethora of those, OpenID, OAuth, Kerberos, Okta, Azure AD, whatever you want. We're not going to go into security. That's a huge thing on its own. And yeah, we're not going into that, because you'll all groan and leave. But there's so much to consider there, and so many different services. Like maybe you want to use Identity Server 4, for example, and implement that all there. There's a lot of different things to think about here, so that's a whole conversation on its own. The one thing I will say though is don't roll your own. I've seen people sort of like try and make up their own sort of claims, and that don't use that. Use something like, you know, or OAuth to, you know, all of these sort of services. Try and implement something that's already there, that's tested, it's meeting up to security standards. Just don't do your own. Do something, implement something. All right. So let's move on to an API gateway. And, you know, what is it? We briefly touched on it at the beginning. This is sometimes called a reverse proxy. It's a single entry point, so it's well placed to control the access. And that also makes sure that your your application is more robust because you've only got this single point of entry. All front end traffic and external stuff has to go through it, and then all the back end stuff, it can be like, oh, it's okay, that gateway is taking care of everything for me, I don't have to worry. That doesn't mean that your back end services shouldn't still be HTTPS. Don't be lazy, don't stick them on HTTP, still make sure that they're HTTPS. Because even if your gateway is doing all of your securing, you don't want to like leave yourself completely open. Alrighty, service discovery. This is sometimes called a service registry too. And this, I couldn't quite visualize this when I first came onto this topic, but let's say, what good are all your services and applications if they can't find each other? And that's what the service registry is. You wouldn't have your food cart in some random place that no one knows about because you're not going to do any business. You need to tell people, hey, we're in this marketplace, come and get your tacos. And I am sorry for making you all so hungry. So let's carry on and see the different types of service discovery. And there are a whole load of services that you can implement. We've got Netflix OSS, so that is Eureka, and that's an AWS service registry. It does load balancing, failovers, the whole shebang. So let me just say, all of these services do a lot more than just register your services. There's Zookeeper, there's Console from HashiCorp, and a whole load more. So when you're choosing one, choose one that works for you and your company and has all the features that you need. But I'm actually going to show you Eureka because I think this is quite cool. I've enjoyed like learning about it and going with it. So let me come in here and go. We are actually going to write some code. So isn't this beautiful picture? This is in Wales. I'd like to go there. Right. So I have this little demo here. And what I'm going to do is just close this. So I have a dad joke API. This is a .NET 6 application. It isn't a minimal API because I upgraded it from .NET 5. But I am just going to run this so you can see that it does in fact produce a dad joke. So why do fish live in salt water? Because pepper makes them sneeze. Oh dear. I'm not responsible for these jokes, let me just say, okay? So let's stop that. What I want to do is get this to register with Eureka. Now I have Eureka running locally in a Docker container. Well, I'm going to start that now. And if we go and look on here, it runs locally on port 8761. It should be ready. There it is. It's actually built on a Java Spring app. And if we come down here, we can see there are no instances or applications registered with Eureka. And we're going to go and change that. All right, so let me just bring that window back up. I'm going to use SteelToe. This is a library or a collection of libraries to help you manage your microservices better. Now, we're going to use the Eureka client in here, and there's a whole load of sort of settings in here that you can do. We're going to do a nice basic implementation. So the first thing we want to do, and I'm gonna do some copy paste because no one needs to see me fumble all the keys because I'm like not the best at typing. So we are going to bring in steeltoe.common.hosting and steeltoe.discovery.eureka. So now on the services, we can just bring in, it's really quite easy to bring it in. I didn't need a capital. Services dot add discovery client. I don't want the configuration, discovery client. No, I said I didn't want the configuration. Thank you, Visual Studio. There we go. And now if we can control dot, we're going to bring in that discovery client. That's all we need on the startup. That brings in some middleware. And now we are going to go into the program and we're going to tell this that we want to use, use cloud hosting. And this is going to tell us which port to put it on. Now, if we go and have a look in our launch settings, we're on 4101 and 44361. So we can add those in here. And was it 44361? And we just need to bring in that. Let's make it pretty. And the last thing we need to do is give it some configuration. And we're going to pop that into our app settings, and the middleware knows to go and look here. I am going to paste this because I'm not going to trust it. We need to tell it the URL to go and look at. So that's our 44361. That's how it's going to register with it. We're telling it to use our local instance of Eureka. We want this to register with Eureka, and we can fetch registry. This is where all the settings go that we saw. So now if I launch this, we can see that we get a steak pun is rare, medium, well done. Oh my God. Now, if I go back to here and I refresh, you can see we've now registered our application with it. And if I click on that, it goes to info. But if I go dad joke, we get a joke. All right, so that's stage one. We can register our applications with it. That's awesome. But how do we go about getting information out of the service registry? So I have a console application just here. I've already done a little bit of boilerplate on it. A console application doesn't come with app settings anymore. So all I've done is tell it to use the app settings. I have also already added in Stilto the same as before, and that's just in there. So just to save a little bit of time. All right, so what we need to do is add in our services dot add discovery client, just as before. And I'm not going to add anything. Why does it do that? You're a pain. You know that Visual Studio, you're a pain. We're not going to add the one to the program because we're not actually going to ask this one to register with the service registry. It's a console application. We just want it to be able to talk to the service registry. So we don't need to do the bit in program, but we do need the client available for dependency injection. I've got this service over here called Eureka Fetch Service, and this is a class to fetch all the apps within the service registry. Now I want this running all the time, so I'm going to set it up as an hosting hosted service. And so I was like, hang on. Okay. So for that to run, we need hosting. Let me just check that no one's asking in there. Okay, so this is saying, oh, you haven't implemented me. Let's go and implement the interface. As you can see, I've just added logging and an HTTP client here. Okay, nothing fancy. So we've now implemented this interface. We can go, well, we've not implemented it, but we can go and add this to our IoT container, and that's services.add hosted service and the name of it. So that bit's done. But now let's actually go and write some code in here. So the first thing that we want to have is actually a discovery client to work with. And I'm going to do some pasting here just to make my life easier and your viewing less painful. So we want that injected into our constructor. We need to bring that in using Stilto discovery, and then we just need to map that over. We're going to bring that in. Is equal to discovery client. No, what did you do that for? I tell you, I thought this was supposed to be like helping me, Visual Studio 2022, not hindering me. I am just going to say that as a discovery client though. So let me do that. And that's just complaining because it thinks I should put, you know, this throw new argument, null exception, name of blah, blah, blah. So, okay, that's happy now. It's just because it's .NET 6. Okay, so let's start doing some stuff in here. We want to get all of the apps out of our discovery client. So we're going to go var apps equals our discovery client dot applications dot get registered applications, and that's, oh wait, I should have pressed tab then. So we've got that, and then we just need to add some other bits in. I'm going to paste in some bits, and yes. So we're going to log it. I've got this count to do at the end, and we're going to loop over all of our apps in there. So we've got all of that, and this goes and gets the very first instance of an app. So an app may have, that's the service, and then it will have multiple instances of that. And then we're going to print those out, and we're going to add a count, like how many there are in there for each app. Now, what I want to do is print the dad joke out to our, I need to put an await there, just to our console. Nope, not an await, an async, and that will make that happy. So again, rather than type, I'm just going to pop this in, and let's have a look. Let me just make this it. So we're going to try and go and do a name match. Is it called the Dad Joke API? Because we saw earlier on Eureka that that was what it was called, Dad Joke API. We're going to make that lower, and then make sure that it's not empty. Now we're going to use our client, and we're going to go talk to that homepage URL and get a dad joke, and then we're going to print that to our console app. Down here, why are you upset? X is... All right, we're just going to get rid of that. I've only got that. I know you shouldn't do that, but I've just got that in case. And then we just need to go and add a little bit to our app settings. So if we go over here, this time we're saying should register with Eureka. No, but we do want it to fetch the registry. And I think, famous last words, that this should all work. And now if I set up my startup projects, I want multiple. We have start, apply, okay. And we go here. And I think I go back into here, I'm going to put a breakpoint here. Yep. What is red and smells like blue paint? Red paint. Oh my God. But you can see that we went and got our things there. Let me restart that so I can step through that a bit slower. But we did manage to print out our joke. Joyful occasion. So we can go through and step over. Did I restart it? It didn't hit my breakpoint. Why did it not hit my breakpoint? Let's see. Obviously did it before because we did the that. Well, I'm not going to worry about that. We saw the dad joke be printed out. I don't know why my breakpoint. Oh, it's this. I haven't closed this down. That's why. But there you can go, and you can see that we still hadn't registered that other application. Alrighty, so I know I'm tight on time, so let me stop talking and get over here and just give you the final words of wisdom. Oh God, Dino, I thought, oh my God, let's not get more dad jokes. Actually writing code. Things to bear in mind is plan the scope of the project. Remember, scope is key. Plan the right solution for each project. If you need to use Go for something, use it. Don't be stuck in your own programming language. Make sure that the data still works for it. Layer in your complexity. Don't go all out with identity and Eureka and API gateways all in one go. Do something, make sure it works. Add in the next bit. keep going, and just be flexible. Change your approach, try something, keep failing often, and keep iterating. Other stuff, this topic is huge. We haven't covered deployment or monitoring. You need to monitor all the things. Availability, so like scaling and load balancing. There's probably a lot else that we need to cover, but this is just a quick guide for you. And then some resources. We have Steel Toe, which we looked at, and it has all of these cool endpoints there. Dapper, that's 1P, no E, helps developers build event-driven, resilient distributed applications. Project Tie, that's still in like an early access version. I've not used that. We got Yarp, that went GA in the beginning of November, and that's what I've used for API gateways. And then that's it. Thank you. Bang on, 12:45. Well done, Layla. Wowzers. So you can reach me on laylap@vmware.com if you have questions, or you can find me on Twitter, on GitHub, on Twitch. You can find me on laylacodes.it or layla.dev. I'm just launching that. I will share a link to these slides in the Discord and a link to the Tanzu Tacos application. I also have other applications that you can look at if I go to my GitHub if you're interested in seeing how Yarp works. So that's the API gateway. I do have blogs coming out next month, just waiting for the Tanzu Developer Center to give me a .NET special page, and I'm waiting. So that's due in December. I show you how to build an API gateway with Yarp. I also got an API gateway with Yarp and Eureka. As we've got a little bit of time, if people want to just see how going through service discovery can be really useful. This is the API gateway with Yarp and Eureka. And this is awesome because we dynamically create all the clusters, which is like the paths, the like phone book, so to speak, for our API gateway. We can dynamically create that and update that every 30 seconds or whatever your time frame is by using a service registry. So just as we did before, this is an application. It's got a drink service, a food service, a client, which is Blazor, and then an API gateway. We can loop through all of our applications that are registered, and then we dynamically populate the clusters, which is what Yarp uses to direct traffic. So that's a great application. I can show you that running if you want, or I want to leave some time for your questions. Why couldn't the GET request go to the ball? It had nobody to go with. Oh my God. I'm glad you enjoyed that. Yeah, I'll be around. I'll check the Discord if you have more questions. I can run this. Does anyone want to see this running? We've got 13 minutes before I'm forcibly removed. I can.
There was also a question about whether there was a service registration service in Azure.
In Azure, yes. Thank you, from Philip. Is that Phil Persglove? Now, I don't think there probably is. I don't know what one it is. Let's have a quick look. You could deploy your own. So I know that if you use Azure Spring Boot, you can deploy Eureka into that. That also supports .NET. So if you go Azure Spring Boot, this does have support Eureka in there, so you can use Eureka in that. So this is a whole Spring-based cloud for Java applications. So I know that you can definitely do it in there, and you can deploy all of your .NET applications into that as well. There's several different tiers, and it's a complete management for your distributed systems, and pretty awesome. Azure Service Discovery. Let's see if there's anything other than that. Does it say what it uses? It has a registry. I don't know if that's kind of what we want, but that's just about the pattern. But for a start, I know that you can do it with Eureka in Spring Cloud. I'll have a look in and see if I can find anything more. So sorry, I can't give you more, Phil, but that was that. So Steve Talks Code says, as well as using for APIs as a reverse proxy, Mark Rendell has a project and talk using YARP in front of a legacy .NET framework application to start splitting it out between parts of legacy app. Ah, that's awesome. Yes, Mark has been doing quite a bit on distributed systems as well. Also, if you want to know more about the synchronous applications like gRPC, the forms of communication, make sure that you check out the next talk from my friend Purnima, who is doing a talk on gRPC. So if you want to learn more about that, make sure you check that talk out. And as James says, there's a feedback form. Better be glowing or I will hunt you down. I'm not threatening. I'm not. That's probably a code of conduct violation. I apologize. I won't hunt you down. I don't know where you live. So thank you very much for everybody. I really enjoyed giving that. If you have any feedback to give me personally as well, feel free to reach out via email. If you thought that demo was useful as well, you know, if you think that would be an interesting talk on its whole self doing service registry, I find it really fun. I enjoy that. Yeah, thank you for James for all his setup as well and looking after our production. So thank you to the crew behind all of this. They're doing good stuff. Yeah, so any other questions?
There'll be a bit of delay before questions appeared from asking. Do you think there's enough time to go through your second demo?
Yeah, we could. I could put breakpoints on that and go through, because I think that'd be quite nice to see that in operation. Let me just check. I'll recycle this. It should just work. So let me go and have a quick look in here. So we should have nothing registered. Good. So I've just restarted my Docker image. And if we go and start this, more food, I'm afraid, folks. So we just have a basic Blazor application. And we've got two APIs. This one's going to bring back a food item, chips and dip. And this one's going to bring back a drink, which is ginger beer. And if we go for a get order, I can see we've hit a breakpoint. So you can see we've now gone into a very similar system. This is extending iProxy config provider, which is part of YARP. It's also an iHosted server. So we actually register this twice. It's quite an interesting thing, which is why I've written quite an extensive blog on it. But we do this update method, which is creating the clusters for YARP to be able to tell things where to go. So if we step over this, let's have a look. How many apps? We've got two apps. You can see we've got the drink service and the food service. So if I go check out Eureka again, we should see both of those registered, and we can. So that's really good. And now if we step down, it's time. So it's going to be having built up. Yeah, I'll drop those links for you in a moment. So we can go through and get all of our apps. And now we're going to create a cluster. So this one here is, yeah, I have to step over again. Because it's on a timer, it does it every 30 seconds. I've been talking too much, so we don't get there. But if I go, let me put a breakpoint here. Let's skip to the next breakpoint. So we can see we've created a cluster. We've got this drink service. It's got a destination, and it's saying it's localhost 44367. So I'm going to take these out. So you can see it's starting to populate the clusters. It's going to be a few clicks to get through that. And if I go over here, is that going to go? Fish taco and ginger beer. And that has routed through our API gateway, which has dynamically populated its routes all through Eureka, using a very similar system to what we did. Now, if I go and show you the code in the gateway, this is the config. So this is extending iProxy config. And then when we come to register it in the with the service provider, we add it as a service, and then we register it also as a hosted service and an iProxy config. So we have to have it in both so that we can hook into the two different things. And then that just runs and updates every 30 seconds, and it will also dispose of itself as well. So it's pretty cool to go through. There's lots of aspects in that, and as I say, there's a blog coming out. So if you have any questions about that, let me know. Meanwhile, let me get you the link to the slides. Where are you? Here. This is the public one. So let me get you a link. So there you go. That is the link to the slides there. So you can go check those out. You can have a link to my repositories there. The demo I did today, I haven't pushed that up today. I'll push that up so it's there, and I'll update the slides with the link there as well. Let's go see. So Craig says, be great to see a deep dive session into each of the roadmap topics, monitoring, deployment, etc. There's a whole session and slide. Yes, there's so much to do in this. Yeah, so that's a quick route. I'll just wait for any questions about that. Meanwhile, I can create a repo for you. And at least give you the link, can't I? So that will be the link for the demo today. And so, and if I go, see if they're just waiting for any questions. It branch. Okay, so it's master. We'll change that now. Oh, reload. Yeah, you can reload. You can go actually. Paste. And then I'll push each of those branches up there as well. I don't see any more questions coming through. James, do you?
I think we're about wrapped up.
Cool. Well, thank you so much for your time, everybody. Enjoy the rest of the day. You can reach me at any of those places I shared.